Hello, this is Kapil Suryawanshi. Uh, Today's topic of presentation is predictive analytics for cybersecurity. So this particular presentation is being done as a part of a requirement of a project submission or presentation submission for the course USC 6376. Okay, let's quickly go through the little background. What kind of audience is being expected here. The course will take you through cybersecurity and its challenges and the answer to them with respect to the predictive analytics. Though the course will, though this presentation will refer to different methods or different models of machine learning, we do not expect that we basically expect that the people the audience should understand the basics behind them. The code is, this presentation is only about presenting how things are used and how they are applied in the industry for this particular domain of a cybersecurity. Okay, all the contents in this course are collected from public URLs, public internet material, as well as context is also brought to you by the book. Okay, so I do not hold any permission to really, distribute this content, whereas I think it's okay to be used for the educational purposes. If you are making use of this presentation or the material in it for any other purpose, I kindly request you to go ahead and take your permission or approvals from the original authors. The references section will have all the references basically. Okay, so what are we going to cover today is this is our agenda. So as the topic is cybersecurity, I will briefly touch upon what are the concerns in the cybersecurity, what they really, what is the today's state of a cybersecurity, right? And there are some traditional and the new approaches to this security. There will be discussion of brief discussion of some of the issues or the most frequent use cases in the cybersecurity and how they are being handled through machine learning. We will talk about predictive analytics as a topic. Just spent a few minutes over there giving a background of it, but not going into detail. We will talk about what is the process when any problem is to be solved using predictive analysis. What is the process we should, or a very top level steps that one should follow. Then we will take a look at what are tools that are available for this purpose for implementing any of these concepts, and we will choose one of the tool named Weka. We will also choose one of the use cases, and we will run through the tool to understand overall process of how things are designed to solve using the predictive analytics. Okay, we'll conclude the presentation with some references as well later. Okay, let us start then. Cybersecurity. Okay, the word cyber, when we talk about, it's all over: digital, cyber, online. These words are all over because the computing power is so cheap these days. We get so many. Even the personal computers are very powerful. The computers that we hold in our pocket, the mobile themselves, are very powerful, and this technology is in the reach of almost everybody, right? So it's a natural inclination to design solutions on this technology. So many of our applications that we use in a day-to-day activity, day-to-day life, they are all either online or mobile app. All the banking applications, they are online. You generally be using any social applications, Facebook, YouTube. You may be using WhatsApp, Twitter, all those are all online. And being online is also for any organization also their intranets, the people how they collaborate with each other, It's basically being online is ensuring that that the company is on 24/7, the business is on 24/7, and different teams in different time zones and geographical locations, they collaborate. And this way, companies are getting more work done. They are increasing their productivity, and they are also reaching to the far away customers by just giving a reference to their website. And the website in itself has virtual presence of the entire company in front of a customer. You can, for example, Amazon, it's a very well-known example. This service is to sell things, and any person in any corner of the world can go to Amazon, create their account, browse through millions of products, choose a product, pay them then and there. They can review the comments of other users of the product. They can decide for themselves, and then they can buy these products, rent out books online, everything. So you don't need a person to be convincing you something. You are just visiting the website. There's entire information. You navigate to related interested services. You pay whatever is required for those services, and you're done. You get the services. So the company is like on 24/7. So we cannot now avoid going online, being online. We cannot avoid. But then this is also creating more opportunities for some evil minds to hack in and steal data, misuse the data, do some illegal activities. So cybersecurity is a second accompanying concern. When everything is getting online, then that online transaction, the business has to be secured, right? Now you need an excellent system for cybersecurity, basically, to really secure this, because as technology is evolving, the advancements are happening. There are many different ways of doing the same thing, simpler ways of doing most complex thing. And because it's a computer technology, it's in everybody's hand, in good people as well as bad people. So on one side we are advancing, and in other side the criminals are also advancing in this term. So cybersecurity is a need of the hour. How do we really ensure things are in a secure hand? Defending on these criminals is equally challenging task, because these criminals or these evil minds, they are in themselves geeks, nerds. They are themselves very skillful people, and whatever technology we may use to secure our networks, the same technology is in their hand to break that network, right? So we may be hearing lots of lots of news all over the internet about this virus, that virus, ransomware, malware. There are hacking activities. Every computer today needs to have an additional overhead software of antivirus, right? We used to really hate those antivirus because they are for our good, but they consume a lot of the power of your computer. So in today's days, our computers are also powerful, so we don't even notice them. But olden days, if antivirus is installed, for every file that I try to access on my computer, the antivirus goes and checks it for me. Now, okay, all it is doing is a good thing, but it is really consuming time, and my computer is slow. Today's days, okay, my computer is fast, but antivirus is a required thing, but it's an overhead. We know that, right? So similarly, firewalls, that's an overhead, but it is required for securing the network. So there are many such things we need to now consider. If you go through any online web reference, one of them is given here. Somebody created a report in 2021 and giving us 10 biggest attacks in 2021. I know this is just a tip of the iceberg. These are some 10 companies which are well known, and Kia Motors, Acer, Accenture, these are well known. Even the Washington DC Police Department, these are well-known and very responsible organizations, they themselves are facing, they're being a victim of these attacks. So here, if you see here, the chart is telling us month-wise breakup of 2 consecutive years, 2020 and 2021. Whatever may be the numbers, what we must understand is as time passes, the total number of attacks which are shown in green are far more than what used to be in 2020. So though we are advancing, we are not solving this problem entirely. The problem is also advancing. Okay, that's we should be understanding. And if you need to know more about these, okay, the website like the one I have also attached in the reference, and many other such websites will give you detailed information of what really happened with each of the company. They will talk to you how many dollars were at stake. 50 million. I mean, this is not a small number. A very interesting thing happened with someone is there was a ransomware attack. So I was trying to understand what is ransomware basically. So a virus program or a piece of a software somehow gets downloaded or somehow gets added onto the laptop. Now there are many ways how do you do it. You may be using already infected media, a pen drive or a disk and something inserting into your computer, or you are already accessing a shared folder which is infected in itself, right? Or you may be downloading some software along with it, some malicious code is downloaded. Other way would be you are just browsing through your email and you happen to click some link which is a phishing link. By the way, that is going to be one of our examples. How does a computer or the predictive analytics would really find out if this is a legitimate link to click or not, and etc. But by any means, such malicious code can come onto your system. And so in the example that I was talking about, ransomware, such a code came on to the system, and it started encrypting the disk, and finally it encrypted the entire disk. And when users tries to start up his computer, he would get a big blue screen with a message saying that your disk is all encrypted, blah blah blah. And if you want to you have this unique key and you have this unique address, a Bitcoin blockchain address, and do send so and so much amount, or even a Bitcoin to us, and only we can solve decrypt your hard drive. So some people do send money because they're scared, because there is no other way. It is encrypted with some secret key by the virus, and that key is not available anywhere. And you can't do if you are totally dependent on your computer. You need to get it fixed as soon as possible, right? So then people did send money to these guys, and the security or the blockchain in itself is so encrypted, and the address where someone would send money, nobody can identify who holds that address, who owns that address, in whose account the money is really going. And and what used to also happen is people would send the money in a hope that those guys will help us send us a decryption key and our computer will all be secured back. But there may not be any answer, and you are just sent the money. It's not just you. The virus will infect the entire network and so many computers. And you can imagine the bad guy would have earned a lot of money while his all transactions are all encrypted because of the blockchain what they're using it. And there is nobody there to really be responsible to unlock or decrypt your hard disk. So these are called ransomware attack. They are they are asking you for a money to get you out of a difficult situation. But they are not legitimate. They themselves have fixed you up, and now they're saying we have the only solution. So in this is a very difficult situation if somebody gets into this. And if imagine this is a personal computer, this is one person affected. But if it goes into some organization's intranet, it will immediately go and affect and get replicated by itself in many computers, many servers, and a lot of money is at stake there. Okay, so this is a serious problem basically. Now, what were the approaches to all this? Okay, there had been a traditional approach. I'm calling them traditional because they have always been there before the advent of artificial intelligence, machine learning, and predictive analytics, before the advent of all that. So what, and they are still valid today, okay, but they are not sufficient. So traditional approach is, okay, having a guideline, please back up your data. I mean, you will see this is foolish. This isn't a technological solution to it, but yes, back up your data can save you from a lot of hassle. In the example that I gave, ransomware, if you had the data backed up, you could have just ignored that ransomware. You could have used the backed up data to set up your computer once again. Right? Sometimes, so this backup, though it is a traditional approach, this is a basic thinking. This is still valid today. So don't get me wrong. But these are insufficient. They are not blocking somebody harming you. They are just saving some hope by backing up. Other things are generally big companies who are hosting this operating system, like Microsoft or Linux organizations. They keep releasing operating system updates. The personal computers are generally avoiding, okay, I don't need, because I don't understand that update, but they are essentially useful. In some organization, IT admin will mandate and spread that auto updates to all of its computer in the network. But ensuring having a latest update of the operating system helps us solving so many defects, loopholes in the system by the vendor itself, operating system vendor himself, and give us a little more confidence. So that was one of the guideline. Please keep your system updated. But again, that is automatically scheduled and it gets updated automatically, but it won't solve the entire problem. Okay, maybe it will make your system more secure, but every day something new is coming out, some new virus coming out, some new way of hacking comes out. That's still not sufficient. We can use some softwares to detect the ransomware, malware, something, or these softwares generally knows the antiviruses. Now, I briefly talked about in the olden days, I used to hate antivirus because it would consume most of the resources of my computer. And today, they are still a piece of software. They are complex software, but the way they were developed in the past, and I think in the today's in today's time, these antivirus softwares have also evolved, and now they are including machine learning and predictive analytics methods in them as well. But in the past, how they were developed was, if a particular virus or infected executable is found, the pattern, the signature of that virus is what is detected, and this signature is stored in some database or in some DAT file. An antivirus would scan your file being accessed to that signature, right? So it is trying to find a binary pattern in that signature, in that another binary file, to say if it is a suspicious file or not, if it is infected file or not, likewise. So this was the old way of doing it. It is still valid, right? It is still valid because some older viruses which still remained in the internet somewhere, they might come to your machine and your antivirus will detect it automatically because it was a known pattern that it knew it. Okay, but this is not a prevention. This most of the times this is not a prevention. The antivirus would update its signature file or signature database only after a virus is detected and the antivirus companies, analysts have extracted that signature. Then they would update the that file, which will be updated in your local computer. So there needs to be some harmful thing, then the pattern is extracted out of it, this binary signature pattern, which is updated in antivirus. Now there onwards, if your antivirus is updated, you are protected against that. But you see that this is an after effect. Somebody must have been uh, damaged, affected by it. Now antivirus software or vendors have learned, oh, what should not happen. Then they kept it. Okay. Other way is cybersecurity awareness training to employees. Okay, so this is again, you would see it's non-technological talk. This is a guideline. Yeah, but this is equally important today, but not sufficient. So, okay, what would be in the training? Okay, don't share your password, or make them encrypted enough. Don't share or open links from unknown sources. Don't open SMSs, spam emails. Okay, so this is again a training to the new employees. Okay, always lock your computer if you're going away from your desk, so that nobody can do some illegal operation with you. And do not access certain sites which are not a legal site or phishing websites. Okay, and so on and so forth. And the other thing that IT administrator would do, that they will monitor their network regularly for using this antivirus, using the firewall softwares or any other method. They will monitor them regularly and try to, in order to be proactive. But then these are the traditional approaches, not not the new approaches. What the new approach will help us is, okay, along with all these traditional things that somebody would do, new approaches include the computer program themselves. So these programs are not a static program like the old antiviruses. Okay, these programs would learn over a period of time and change their behavior. That's how the machine learning, artificial intelligence terms are being coined. And if they learn from by themselves, they are in a better position to understand the behavior and predict near future what might be going suspicious. Okay, so giving us some more time. So that's the first point of it. How the software do their work is they forewarned, is forearmed. They predict things before they happen. Okay, they predict, okay, probably this is going malicious, or this is going suspicious, this is going out of usual behavior. So it creates an alert, and this is how administrator have some advanced warning, and then they can take a look at it, really what's happening. Okay, it can handle huge volume of data, and now that's the big thing, um, everyone going online, and everyone making use of internet. This is, this is enormous data available and getting generated every second. You might have heard millions of images are uploaded on Instagram every day, or millions of posts are made on websites, or by the bloggers or in the social websites every day. So the data is huge, and so that's what, and it is coming in all forms: video, audio, a normal text, or a behavior pattern. So this data is unstructured basically, and it is available in all forms, and moreover it is continuously getting available. So it is stream data continuously is available. Now a human administrator who is responsible for the security of the organization in no way is in a position to really analyze this data to find out any problem. It's like um, finding a needle in a haystack, and that's unthinkable and impractical. Having a machine learning solution help us do that. Okay, so there are two things here. Because it's a machine, because it's automation, it can really take a look at big volume of a data in relatively short time. And second thing, because it's a machine learning, the learning is better with large amount of data which is used for training. Okay, so that's the advantage on both the fronts. It can handle a big volume, and when you learn with large samples examples, the model becomes effective. It automates much of the workload, and that's a side effect of it. Because it's already a program, it can be automated, scheduled to do its activity, or it can be triggered to run on an event, you know. So you don't need a human presence to start it up, stop it. The computers are scanning the network all the time, the files and shares all the time with their machine learning algorithms. By doing that, it takes some pressure out of IT department really about security. If they have the software installed, they have some confidence and some assistance in their job. And there is another approach to the solution is it's not the way antivirus used to do. They would store some interesting patterns or signatures and try to compare the same signature with all the files under question. Okay, that's a static software. It will just do exactly same thing if you run it million number of times. But here in a machine learning and predictive analytics, it goes beyond that. It is learning by itself. And then what all things can you learn? You can learn a pattern, of course, but then you can learn a behavior. A legitimate user would do these activities in these hours during the day or these days during the week, you know. Tentatively it would learn a legitimate user's pattern of interaction with the system is so and so. If somebody is not following that pattern, then it can alert the administrator, okay, there is some suspicious behavior. Okay, this is, for example, if it is expected an employee to work during the official hours, and suddenly on a very, late in the night, somebody is accessing or unlocking, accessing some file, this is suspicious behavior. Okay, maybe the software, if there are sufficient information, he provided whatever security keys and passwords and this, that. If there is sufficient evidence that this is a legitimate activity, that's well and good. If it is not, it would, the software, the predictive analytics softwares would, algorithms would warn, okay, there is something fishy going on here. Okay, some other things are, other activities are to know your presence, basically. Are you there really what you are saying you are, right? Even though you have all the security code and all that, you may be asked a biometric. That's an additional level of security. You may have two-factor authentication applications like Duo or Google Authenticator, or there are, they will give additional code, or the systems would send you in your email some code. And if you are really the owner of the email, or if you are really the owner of a particular mobile number, you will receive that code and you will further authenticate, saying, okay, yes, I am the real one who's holding this ownership of the account, etc. Okay, so these are the new approaches, and these AI model can fill gaps in where the human abilities fall short. So I said, because it's a tremendous volume, big data, you need a more processing power. Only computer programs can really do a lot of processing in relatively short amount of time. And similarly, if because it's a program, it would relentlessly keep doing its job with a 0% error, right? A human over a period of time doing the same job will get tired out of it, and then slowly start introducing human errors in the system, in the entire process. Whereas these automated programs remove these gaps, and wherever the human abilities are falling short, they are helping the businesses to stay safe. And you know, over the period of time, if we are using this application, they will give us confidence okay, because they are learning, they are growing, they are making themselves intelligent over the period of time. So we get some confidence that we with the time these applications adopt the situation, they change themselves, they improve themselves. uh, it is not like the antivirus which when not updated goes out of date and its scanning is ineffective. Okay, now with this as an understanding, we just saw what all we just saw what the cybersecurity involved, what challenges it involved, what approaches were there in the back old days and now today. Let's go through some of the issues or some of the use cases which are solved by a machine learning, okay, in cybersecurity. One of them is SMS scams, and even today I keep receiving so many calls with illegal, uh, so many maybe credit card frauds and so many calls about, okay, I have this offer, that offer, do you want to enroll, all that. And I also getting many SMSs in these days because COVID-19 time, in this pandemic time, everyone is scared and the bad guys are really interested to make use of this situation. So under the, whenever say somebody spreads the news of a COVID-19, people are already so cautious about it. They might believe each and everything is true and start acting on it. So there are so many rumors also all around. So using machine learning as a technique, or predictive analytics as a technique, such a SMSs, illegal messages, can be scanned and categorized that they are phishing. They are scamming people. They can be avoided. Okay, so that's one use case. Another thing is securing mobile endpoints. The example that I gave here is, in our house, we have a Google Mini to which you will talk and ask maybe weather and routes and information on some or the other things. And when my wife talks to it, it understands that which account it should be accessing. My son talks to it, he behaves separately. Even the person responding changes. When I talk to it, it will change. So basically, when I say, okay, how's my day look like, it goes and accesses the location where I am. It first gives me a weather information, then it goes accesses my account, client, calendar. It gives me listing of all the agenda of the day. It also gives me understand where is my, what is my work commute time. It would generate some more alerts saying, okay, some bill is pending. I have received an email of say light bill, electricity bill, and it said, okay, this is due today, and etc. etc. So basically, this is small conversation, but it really goes and accessing the data of my account and doing a lot other things. In case somebody comes and try to mimic my voice and try to get the same information, it is going to be so tough and so insecure. So securing such a mobile points or endpoints is also a job of a AI-driven assistance, basically. Okay. Enhancing human analysis and safeguarding against human error. So this is one of the examples. MIT has introduced a system called AI2. The link will really take us there, and it will give us some information about the project. There is a blog which will talk about what they really are doing, but basic thing to understand here is uh, there are some systems which are trying to find and analyze threats. Okay. Again, the term, they call it as finding a needle in a haystack. They're saying that because of the huge continuous addition of data all over the internet. Okay. And as we are speaking, we are watching a video, or we are uploading images, and posting comments. It is data all over. From this entire data, we do not know, as a human, do not know the relation between them. There are hidden relations which can be uncovered by the program, by learning the pattern, the way things are happening. They can understand the sentiments. They can understand some suspicious behavior. So they are enhancing basically humans analysis, safeguarding against human errors in that terms. Similarly, as I said, the older approaches to antivirus software is also evolving. Now they are embedding machine learning in them. They are detecting the better or new upcoming viruses. So having a intelligent program, you don't need a regular updates of a signature. Regular updates are still okay because of the old static viruses, but new behavioral, the viruses which change themselves, or the malicious code which also dynamically adapts to a situation. Such code, if you need to be safeguard against, you need your solution also to be dynamically adapting to it. So machine learning algorithms are used in the newer versions of the antivirus software as well to enhance the cybersecurity. Similarly, monitoring email. Nowadays, what happens also is when I'm accessing my company's email, some emails are automatically routed to spam folder. They understand why they are spam, or they're basically automatically guarding me, saying, okay, this is something unusual. This is not coming from a recognized person. The message it contains, it doesn't look like an authentic message. It's not official communication, and it probably is a virus, or it probably has some phishing links in them, which I might click and get into bigger trouble. So they automatically are moved into spam folder. Some solutions also recognize, they let me open the email, but they add additional header on top of it that for so and so reason, this email doesn't look legitimate. If you want to report this as a spam, click here, right? So that's my company's security system. It's monitoring my email. This all is done by a natural language processing. Now, and that's required, this is a text written in whatever language it may be. For me, it is in English. For other countries, there is other language of business in which the emails are written. So then machine learning algorithms needs to understand what is being communicated, and therefore the big field of artificial intelligence, which is natural language programming processing, those algorithms will help to understand and make a meaning out of it, to really safeguard me against them. Okay, another thing is, and it is getting prominently more and more interesting, is there are bots all over. If I go on a website, I'm just browsing through it, something will pop up from the bottom right corner asking me, okay, do you need any more assistance? And then it is given a name, for example, Natasha, colon, and then there's a message, do you need any assistance, blah blah blah. If I start responding to those messages, you will immediately understand that this is a bot communicating with me. No, there is no real person Natasha behind the scene. So this is one way people trying to use bots to do some usual activities, usual queries a customer would have, can be easily answered. But then there are bots also in a let's say a chat room, right? It is pretending to be a particular male or female and trying to communicate. This the communication patterns are in the form that the opponent will reveal some sensitive information which can be utilized by some other way. Other thing, other approach to this is, okay, there are good bots which are helping their customers to have frequently asked questions answered. There is bad bots which are personifying and trying to get some sensitive information from you. Once they got it, the third kind of bots are they will assume your personality and try to, you know, own the whole account and try to do things on your behalf. Imagine somehow a bot logging into your banking application with your credential and then transferring your money to somebody else, and you would not even know that and until the money is transferred, gone, and then the alert comes, okay, you have transferred over limit. You now go and look for it. Okay, who did it, what happened, can I get it back? Okay, the time has already passed, you know, it's gone. So there are some bots like this. So we can't say that all automatic actions are bad, but we need to now understand which is a good bot, which is a bad bot. So there are some patterns that talk about here is, okay, these bots being a program, another program, they will quickly connect to this server, that server, replicate themselves here, there, do some actions. Okay, that's a, or there is a unnatural pattern for their interaction. So somehow such patterns, if we could recognize, we could block certain bots. So that's machine learning we used against the bot. There are some network threat detection. Now that is a further complex topic because um, the interaction that we just talk about, the email just talk about, it is we as a human going to interact and decide something and do something with it. But network communication is all binary packets in you know, variety of different packet formats and network formats. Either it's IP packet, V6, V4, and inside them there are so many embedded packets. There are many application protocols use. Is it HTTP, FTP, you know, mail? So on the network level, when you see these packets, these are binary data being exchanged, and it is a huge high speed communication happening, data going in and out on this high speed runway in the traffic. You need to understand what is a legitimate data, what is non-legitimate data, to understand a suspicious pattern. So in case you one could identify with the program, one could identify this is a malicious communication being you know, being run. The network software itself can block it before you engaging into much more things. Okay, for example, a virus already exists in your on your machine. You are not doing anything. You are maybe just reading some article, but virus is doing its work. It may be searching files in your folders and transferring those into some remote locations. Now, if there is a machine learning application monitoring the network, would understand without user interaction something is going, you know, and to a location which was never used, with the speed, with the particular encryption. So this is unnatural. Let's block it because it looks like a threat, right? So the virus's motive will be will be blocked there. And the very similar counterpart, or maybe a parallel part, when we talked about bots, there are other AI-based threats. Now, because artificial intelligence is a technology, it's a science, so many resources available all over. And now with the freeware softwares, we have so many ready-made tools to implement and run through some algorithms. Okay, this is available to everybody, not just for the good guys, but the bad guys also. So bad guys may make use of these machine learning programs to keep finding novel ways to break in. Now, when these programs, they found a new way, we as an administrator or we as a company organization should be in a position to quickly react to it and, you know, block such behavior. So the machine learning is used to alert human authorities in case of discrepancy in the data, like some previous threat. So they would try to you know, safeguard us against. So it's basically AI against AI. They're they're fighting to each other now. So let's now spend a little time. So where are we in our track is, we just talked about some examples. We will spend a little time on predictive analytics, what it is basically, uh, and a related term to it like machine learning. So I might use these terms interchangeably in the rest of the presentation. Whereas what is predictive analysis? It's basically predicting your future from your past, whatever, by identifying hidden patterns in it. So that's a concept. Okay, how do we predict? So the entire artificial intelligence or analytics as a whole is divided into descriptive, predictive, and prescriptive. So descriptive is describing what's the current problem is, current situation is. Predictive is going a little bit further, saying, okay, what might happen in the future. And the prescriptive is giving you some more options, how to, what options to choose to avoid that happening if it is unintended. Okay, so now we are at the predictive level where using the old data, old patterns, the things we have learned, we are predicting what's going to happen in the near future. Okay, what the machine learning is, a tool in this context, is the way of doing artificial intelligence in this context, is the ability to automatically learn and improve from the experience without being explicitly programmed. That's what we need. Until now, all the programs are static. They do exactly what they are asked to do, and they keep doing that million number of time without a break, right? So that's a static way of doing certain algorithm, certain operation, a procedure, step by step. But today's program, when we talk about machine learning, they need to adapt to the changes. So they continuously learn and perform accordingly. So the main reason we are now talking about predictive analytics in cybersecurity world is we need to know before the damage happens. We need to identify such victims of, either they can be devices or the actual humans, and take action proactively, right? Prioritize alerts. Some systems, once running, they will give us, keep giving us alerts. Okay, this is suspicious, that is suspicious, but we can still say, okay, this is a more serious issue than the other one, right? So we need to understand, and we need to be ready before big damage happens. That's why we are talking about predictive analytics in cybersecurity. And on the similar side, we are also talking about it because only the program, the automation that we created, and the processing power that we have today at our hand has sufficient power to crunch large or consume, analyze large amount of data in a relatively short time, which is impractical for any human to do it. And then looking all together, it can find some relation between them without understanding, without a human having the capability to understand everything. The program themselves can try to relate things, find a hidden relationship, and that's what is um, a greater advantage. Okay, um, so so that's why we are also talking predictive analytics in terms of cybersecurity. And then of course it will give us some insights by simplified visualizations that we can understand, like particular charts or heat maps or some time series charts and etc. Okay, so that is why predictive analytics is important for us, and we just gave a glimpse of it, what it is. We'll now talk about it. If you want to employ predictive analytics, what are general steps that we go through? Okay, so I borrowed this diagram from the textbook for one of the use cases, but it gives us a very good high level steps which are used in any of this predictive analytics system design. Okay, so what the first step is data. Now, data is a new gold. Why they say that is um, because everyone wants to be ahead of the game. They want to have a advantage over the competitors, right, in the market. That's why people are investing heavily in artificial intelligence, machine learning models, and analytics softwares and all that. But the only thing, the requirement is this software would perform better if they are learning better. They can learn better by having understood and analyzed huge data. So as big data as you have, that better the model will learn from the data, and that better it will perform. So data is really gold. Why this is, the company who has access to the big data, they can really take advantage of that data, large data. So now, though this is a fact, it's not easy. Just because you have a data, you're all good there. There are majority of time among the steps that we will see that this data is going to be sourced by variety of sources in variety of fashions, variety of formats. They may be as good as a data coming from a database. Now we know exact schema of that data, which tables it is coming, what columns it has, the data type of each column, legitimate values it can hold, and referential integrity, etc., etc. So that's a structured data. But the communication happening on social media, or the stream of data that is coming in, or the posts, I just do it, I write it and note it. These are just plain English sentences. This is unstructured data. I might record a video, that's unstructured data. This is a binary. Okay, unless a software is there to understand that binary, I can't see the video. Otherwise, it's just a binary blob sitting on my hard disk. Similarly is with the audio. Now, these data, once we want to consume this through our programs, we need to process it. So collecting the data is one big step. Okay, so you need it. Your organization should have all those sources, or you need to buy data from external sources. There are many sites which will have some sample data which is used for research purposes, which we can borrow them as well. But collecting a data within the organization itself is a challenge. Now everything is to be collected and merged in some one consistent way so that it can be fed to the program, and now program can make a meaning out of it. Okay, so pre-processing is another very important step. After we got a collection, pre-processing is an important step. In that, you would really, generally the data is converted into more consumable format. The errors in the data, the inconsistencies in the data are removed. So that's one activity required. Then we try to get a data which is a balanced data. So a data should give us, if it is saying, if the data is required to analyze and decide between yes or no, then we need equal examples of yes, almost comparable equal examples of yes and no as a training for the program. Otherwise, program will be biased on either side, right? So we need to balance such a data. There are need for transforming data because different attributes or different things are in a different scale. For example, if a data contains a human financial data, and there is a field like age, it will generally range from 1 to 100. And while there is a field like income, it may range, if it is annual income, it may range from whatever, 0 to $1 million or more, right? So it's a huge difference in the range. And so if you consume such data, it would create a partial bias regarding the huge values. So mathematical equations which are used in this program will get biased over it, right? So such things are to be transformed equally, or generally they call it normalized equally. So such a data is all brought into one particular comparable range from 0 to 1. and then fed to the software. Okay, so such things are required. So majority of a time is spent in collecting and pre-processing data so that it can be consumed. What is that we do? The next is first understand what is our problem. Are we trying to is it a classification problem, that to understand is this a good, bad, etc., that kind of a classification of the data, or is it a regression problem which says that okay, this is the the input would say okay, on this date that was a cost of a certain item, and this is the inflation, etc. And so what will be the cost of the same item over 2 years, right? So at that time we are trying to find a cost which is one number out of from the given data. So that's called a regression. So you need to understand what are we trying to do here. Okay, once we understand, then there are set of algorithms available to do all those things. So there are several algorithms, and each algorithm has its pluses and minuses. Now, some of the examples given here is decision trees. This is a good algorithm which is used to classify data into multiple classes. Then there is a neural network which is modeled after the neurons in the brain. So each dot is a node, and which tries to learn from its input and tries to provide an output to another node. Okay, there is a logistic regression function. This is one algorithm of how to classify. There is support vector machine, another algorithm how to classify. So the support vector machine is more statistical based and more advanced than any, say logistic regression. But then it has its, because it's advanced, it is complex. For example, it may be accurate, more accurate, but it is then more complex, etc. So there are individual models. We need to then make use of each of them and try to understand what are they, how are they being used, what are they going to run through, produce, what is their accuracy, and then choose the best one out of it. So that's an individual model. While ensemble models, these are the ones where we combine multiple models with certain mechanics, certain thought process of bagging, boosting, fusion. Okay, so we try to make use of all of them together to understand a to give the better result. Okay, now the model in themselves are so complex, what they do not explain how they are doing it. Okay, for that purpose you need to understand, you need to generate some metrics to compare this model with each other. So sensitivity analysis is when required when the model does not tell us how it has produced the result, though its accuracy is good. We need to understand how really it is doing it. So we then also calculate sensitivity for the model, which attributes or which data affecting its decision more or less, that kind of information we understand. Okay, so all these things we do. Ensemble models are the merging of multiple models to get a combined result which is more effective, but they are more difficult to implement. Individual models are individual algorithms. We try to choose the best out of it for our purpose and then employ in our work. So when these models are done, evaluated with the mechanism, like one of the mechanism given here is one of the testing mechanism is tenfold cross validation, right? So this entire data, that is training data, we try to we convert them into 10 equal parts, and then we take out one part and train the model on the rest of the 90% data. Once the model is trained, we test that on the part that we took out. This process will be repeated for each of these pi of this circle, right? So, and then finally we try to get some average out of all these models. So that's how we try to test it, and this testing will generate some metrics for us so that we can compare the models, and we need to generate some other metrics so that we can understand how models are behaving to different inputs. Once these models are done, they are basically a mathematical formulation of this entire behavior. Now that formulation that we have, we need to deploy it in the real world systems wherever it is required to be performing. Now the deployment is in any platform or programming language or tools can be used to re-execute those formulation and really make use of this prediction power of it. And then we, to this model, we fed an unknown input, and the model will produce an output. It will also produce a confidence level many times, so we can understand. Okay, so this is how the basic process will go through. Now what we will do here as an example, we will take one example, and I have a data for that example, and we will run through one of the freeware tools to work through it. Okay, and we'll try to follow the process, whereas I will skip some of the process which will be too time consuming. Okay, so now what are the available tools that we have? Basically, once these concepts, these theories are out for the public to use, many companies getting into, and they are really adding a lot of commercial tools, freeware tools, and they're very, now it is very popular. Programming languages like R, Python, SQL, similarly Java. We have a plethora of libraries for each of them, and these libraries are now available ready for us to use. So one of them is a Weka. Weka is a platform, and that is what we are going to use for our example or demo. Now, what we really going to do is let's introduce Weka quickly, and then on top of it, we'll see um, how we can make use of it. This is a website where Weka as a tool is introduced. This is a University of Waikato, and in New Zealand, and they have created this as a platform. It has collection of all the machine learning algorithms, and it is relatively easy to learn. That's why I picked it up for our example. It is developed in Java by the students there, and it is used to teach them. And then there are many videos also available online to teach them. Okay, this is a free software for us under GNU public license. How it looks like, a very minimalistic design. I thought so. As you launch Weka, that we will see in some time, you will get a main interface, and then there are different applications which are launched from it. We will spend most of our time in the Explorer application. And this application will give us information on analyzing, pre-processing all that data, visualizing the data, and then gives us inbuilt algorithms to classify the data, cluster, and other things. Okay, and we will feed the data in a particular format to it. Okay, let's see the demo in action. We will follow the same process. I have some files. The example is borrowed from another website. Okay, I will just quickly show you this website. This is the machine learning repository website, and it has a lot of examples, data sets available. These data sets are donated and used for research purposes also. So one of the cyber security problem is a phishing website. That's what we will be discussing today. I downloaded the data from there. You can just go through this website and see there are many other topics for against which you can find the data. Okay, so that's a free one to use. So I used it. I downloaded one training data set. We'll talk about it. The process that we will go through is all exactly same, but I will skip a little somewhere. Okay, so let's go to the data that we are going to use. The problem is a particular website is available to you. Okay, particular website is available to you, and you need to understand, is it a legitimate website or is it a phishing website? Now how do we determine whether it is a legitimate or not? And that's what the people have researched and found out some features of this data set, and I will take you through them now. Okay, so the data, here is the data. The data looks like it's a textual file. It is prominently it is a comma separated values. Okay, and each row represents one sample, one instance of that data training set, and likewise there are a lot of approximately 11,000 samples here. Okay, and what of each of these are, we will talk about it. So these are each fields which are attributes which are defined here, and the values that they can have. So for example, the first one, -1, it means that does your URL has an IP address? Okay, no, it does not. Yes, it has. So that's how we created the first attribute of it. The second attribute, URL length. So there is a description. What is a particular length of the URL? Is it within a limit? Is on the limit or beyond the limit, etc. Okay. Have you used any shortening service? So generally we generate a corresponding short URL if you want to share it somewhere, right? So have you used a shortening? Does it have an @ symbol? And so on and so forth. There are approximately 30 or so attributes here, and then the last attribute is a result attribute. That's what we want to now understand. Once we characterize the URL with these different aspects, now that we need to understand whether it is a phishing URL or it's a legitimate URL. So I will quickly take you through. There is a good documentation associated with it. They talk about different attributes. Okay, so the one we just discussed. So for example, if there is a URL like this, it probably is a phishing website. Why? Or there is a URL like this, it's a phishing website. Why? Because the domain is not registered. There is no domain name here. It just directly hard-coded IP address. So it is not registered. Maybe it is not a legitimate in itself, right? So there is a rule here. If the domain part has an IP address, probability that it being a phishing website. Otherwise, it may be a legitimate website. Okay. Similar thing, for example, let's say @ symbol. Okay. If a URL having @ symbol, it may be a phishing URL. Same is here. The one of the field says if URL having a double slash in it, okay, it may be a phishing URL because it is trying to redirect us somewhere else. So here it says this is the URL legitimate.com, whatever. Okay, we have a domain name. We started thinking, okay, this is all good, but then there are 2 slashes. It means that this is going to redirect us somewhere else, which is some other URL here, right? So if the position of the last occurrences of double slashes in the URL is greater than 7, that means this the URLs always start with the protocol number 1, 2, 3, 4, 5, 6, right? If it is HTTP or if it is HTTPS, there will be one more character here. So these first 2 slashes are just separating the protocol from the rest of the domain name and URL. And that's legitimate. But here onwards, we shouldn't be seeing double slashes again. If we start seeing it, okay, that is our indication. It may be a problem. Okay, so likewise, they got some rules and these different aspects of it. Different aspect of it are being converted into a numerical format so that the algorithm can consume it and decide on it. So one another interesting is, okay, are you using a non-standard port, right? If it is HTTP or any of the protocols which are standard protocols, you don't need to use the port numbers. The service understands the port number automatically. But sometimes if you are adding a port number in yours by yourself explicitly, it may be a thing that you you have been asked to go to an unstandard place, right? That may be a indication of a phishing. Okay, so likewise, this data is prepared here. Now, when we want to, so this data we will feed it and to the system. So in the first example, some attributes of that URL are having some values, some have 0, -1, etc., etc. But the conclusion is what we are also feeding to the system. The conclusion is, okay, this is not a phishing URL. This is maybe a legitimate URL. That's what we are telling it. If you see this kind of a thing, okay, please consider this as a legitimate URL, not legitimate, or somehow. Okay, likewise, we are telling. So every last thing is a result. We will feed this to Weka, and Weka will build model for us. We will then make use of these models. So this data collection and processing, that part we already have done, okay, to save time. And now we are going to experiment with the design. What we will be experimenting is with few of the algorithms. We will feed that data, the algorithm, the tool, Weka tool will build a model out for us, and it will also generate certain metrics. Then we will compare those metrics and try to find the best model out of it to be used. That's how we are doing the experiment. Okay, so here is a Weka system, Weka tool. Okay, I click Explorer. This is what the Explorer would look like. The first thing I would do is open a file, and my file is available in the demo as a training data set. I open the file. This is ARTFF, that format, right? The way we thought we first describe what each attribute is, and then from some point onwards we start giving the value, the actual data. So the file have understood what columns it would have, 30 attributes, and the last column is the result column. Okay, it has 11,055 instances, and there are different attributes. We are saying last one is the classification column, and for each column that I highlight, it will give us an indication how many are good and bad samples it includes. Okay, so for example, let's say port, right? What it says here is there are 9553 count, for which the port value is set as 1. That's a good port maybe, or bad port. And there are 1500 or so for which the a non-standard port is there. So this is giving us a data among 9,000 or so samples where the port is a good one. It has some negative phishing URL examples and some legitimate URL example. Among these 1500 and so examples where we say this using a non-standard port, there are still some legitimate and some legitimate and some bad phishing examples. So likewise, they're giving us the visualization. By clicking visualize all, we can still see the relationship further for every attribute to get us a little more glimpse in how the data is arranged. Okay, so if there is if there is some regression problems, you would have some different chart of a scatter plot showing relation between the two attributes to each other. Okay, likewise. So now here I can go ahead and do some data processing. So I can click here and give some processing filter. There are plethora of options available here to us. For example, let's say normalize. What does that mean is if I run through the normalize, apply through the, I'm not going to do that because our data is already normalized. It's in the range from -1 to 1 already. We are not going to do anything else, but we can choose these options automatically apply. Then that entire data set gets normalized for us when we need it, and etc. Okay. Once we understand our data set, we pre-process, and we are now going to do the experiment. We move to the second tab of classify. In this tab, we have many of the applications of the inbuilt canned um, algorithms available to experiment with. Okay, so for example, I'm going to run a logistic regression, a simple logistic regression on it. So there is some information what it is. So we will just choose 2-3 algorithms. So let's say logistic regression. I say, give me, please use cross validation, the tenfold, and result is what is the output I'm expecting, and I will train the model on this particular data set. So you can observe the values statuses here. So it's doing training and validation for fold 2, fold 3. That way it will go to the until fold 10, and then give us a final statistics. Okay, so what I will do for the saving time, the rest 2-3 models that I will select, I will quickly build them and forward the video there. Okay, so the first model that we build, simple logistic model, you see we got the output, and it has collected averaging out the accuracy to be 93%. Right, what does it mean is it has correctly classified instances 93%, incorrectly classified almost 6%, or this is almost 94%. Okay, and then it also creates us shows us a confusion matrix and create some other metrics for us. Okay, calculating precision recalls and F1 measure, F1 scores, etc. ROC, area under the curve, and all those metrics. Okay, so what I will do right now is go ahead and execute, and we'll come back and discuss further on each of them. So here we have now built 4 models. Okay, we started with a simple logistic regression. We got the accuracy to 93%. Then we went for a neural network. I just went with all the default parameters, right? This neural network had just one hidden layer. I didn't configure it anything, but it has given us 96 point whatever percent there. And the tools will also give us this tool will also give us whatever weights for each of the nodes. So as there were 30 inputs, right? The first hidden layer will have 30 nodes, and then the first layer will have 30 nodes, and then I think sigmoid node 25. So it looks like the middle or the hidden layer, the first hidden layer had another 25 nodes or so. And then finally there was a yes no classification that has come out. Okay, then I also executed another model, which is a support vector machine, SMO. This model gave 93% of accuracy on this test data, right? And then there are other things, confusion matrix here. And then I ran random forest, one of the trees algorithm, right? It gave me 97% of accuracy. Okay, so let's go back to our presentation. So on the different fact, when we collect all the metrics that are derived from the model, we understand, okay, random forest is the best model for this particular problem. And then that's what we would choose, right? And now what we need is an example. Uh, we are not deploying it anywhere, right? We will just use the same model to execute on some unknown input. So we will now look at the prediction. So with respect to the prediction, I have another file which will use as input. And what I did in this file, at the end where there is a result, expected result, I have put a question mark. Okay, so I will use this file to execute and get us the information. So for that purpose, what we'll do is we'll use a supply test set. Okay, and in this I will open a file. This is my testing file, and it has just one instance. Okay, and I want to predict class. From this, we have to go to the more options. In this more options, we should say output prediction. How do you want to output the prediction? I can say plain text or CSV. Let's say CSV. Okay. We really don't need anything else. So I'll just remove them. I'll just keep this one. All right. And what we do, we right click on the model and say re-evaluate model on the current test set. That's what we provided in the supplied test set. Okay, so now the model executed, and that model has given us an output. It just says that there is just one instance to predict. The actual value of that instance was given as this, right? The predicted value is -1. What that means is the URL that we are trying to test has given -1. That is, it is not a phishing URL. Right, so that's how we built a model, we analyzed which model is the best, and we chose that model to predict any unknown samples. Now this model can be implemented with the related details of how the mathematical details of it, and the information the model will give us with all the parameters. This model, I can save it on the hard disk and load it later point of time, or once the model is built, I have this model parameters to be implemented in any other programming language, depending on where it is being implemented. Okay, so that's the complete round of these processes in Weka. So we are concluding it now. So predictive analytics using artificial intelligence and machine learning. Now it has a tremendous power because of the fact that it learns by itself. So now it's the limitation of our imagination in what situation this can be employed. Okay, so phishing URL, this is one thing. We also saw many other use cases of cybersecurity challenges, right? So anywhere in any different situation, if it is presented to it, it will learn from it and try to accordingly respond. Okay, state of today's technology enables detection of a suspicious situation well before they happen, and that's the best thing, because it helps a human IT administrator to become proactive, right? Not fixing the problems later. He is well equipped with all the things for any possible problems that might come, or security threats that might come. But the fact is, though this is an advanced and highly potential technology, the way of solving problems, this is also equally available with the cyber criminal. Now it is finally is going to be the war between machines or the algorithms, the good algorithms which are AI based and the bad algorithms which are AI based. So it will be an interesting thing to really watch what happens. And here are my references. The primary reference of this entire presentation is from the textbook, Analytics, Data Science, and Artificial Intelligence by Sharda, Dillon, and Durban. There are very good references I found, and a different aspect of them were noted in the reference sections here as well. Okay, and that concludes our entire talk on the presentation, which was required for predictive analytics for cybersecurity. Thank you.